Hello, my name is Shuhong Chen. I'm a PhD student working at the University of Maryland, College Park with Professor Matthias Zwicker. Today I'd like to present our ECCV2022 paper on improving the perceptual quality of 2D animation interpolation. Traditional 2D animators typically draw each frame manually. This process is incredibly labor-intensive, requiring large production teams with expert training. But by leveraging recent advancements in video interpolation, an animator could potentially work by manually drawing only a fraction of the frames and using an interpolator to assist the drawing of the rest. However, the 2D animation domain poses unique challenges to frame interpolation as opposed to natural video. Prior work by Li et al. Began addressing some of these issues through their anime interp system, focused on improving optical flow estimation and providing a benchmark anime triplets dataset for training and evaluation. However, many challenges remain after anime interp, which we address in our work to achieve state-of-the-art perceptual quality on 2D animation interpolation. We first addressed the perceptual artifacts present in anime interp outputs. Li et al. Were focused mainly on optical flow estimation and didn't handle many of the problems in the soft splat synthesis network they used. In contrast to anime interp that blurs outputs, our system trains on the LPIPS objective instead of L1 to preserve lines and details that are important to animation frames. We contain an occlusion mask infilling component to reduce ghosting, and we use a lightweight UNet with a frozen ResNet feature extractor as opposed to a GridNet. Our synthesis network, which we call SoftSplat Lite, achieves better quality results with 35% less trainable parameters. Secondly, we notice that cell-colored frames have more solid color regions than natural images, posing a challenge to ConvNets that favor texture. To improve performance in these areas, we designed a refinement module leveraging auxiliary information from the line drawings inherently present in 2D animation. We extract a frame's line drawing using difference of Gaussians, obtaining a dense normalized Euclidean distance transform image. We then warp this image according to the flows in order to provide additional line proximity signals during refinement. This distance transform module, or DTM, not only removes minor aberrations from solid color regions, but also corrects entire enclosures if needed. Thirdly, we remove the need for manual data collection. Unlike natural video, training an interpolator on raw 2D animation reduces performance. This is due to animation's lower frame rate and extreme nonlinearity between frames. While anime interp manually collects the dataset for training, we propose a new metric called Restricted Relative Linear Discrepancy, or RRLD, to programmatically quantify and filter out nonlinearity and uneven spacing. Using our metric, we double the size of anime interp's ATD12K training set with no manual effort, leading to improved generalization error on their benchmark and allowing future work to leverage widely available 2D animations for training. Lastly, we contribute a perceptual user study establishing LPIPS and chamfer line distance as more appropriate measures of animation quality than PSNR SSIM used in prior work. While anime interp focused on PSNR SSIM evaluation, we found that in actuality, averaged over more than 1,600 forced choice pairs between our full model and anime interp, viewers consistently preferred our outputs, which had better LPIPS and chamfer scores, but worse PSNR SSIM. To the best of our knowledge, we are the first user study to examine chamfer distance in the context of perceptual image quality. We hope our study of the perception distortion trade-off guides future work to emphasize perceptual quality for 2D animation. In summary, our proposed methods improve the perceptual quality of 2D animation interpolation. We redesigned the synthesis network to reduce artifacts, proposed a custom module leveraging domain-specific line information, and scaled up training data collection with an automated filter. We achieved state-of-the-art LPIPS and chamfer scores on the ATD12K benchmark, validated by our user study establishing their use as perceptual metrics on 2D animations. Please refer to our paper for more detailed results, additional examples, and an ablation of our model components. Here, we demonstrate our system on a full animated sequence from the anime Konobi, which was used as part of our validation set. We produce a slow-mo effect at 6 times slowdown with comparison to anime interp. Notice that in the anime interp output, there's severe ghosting on the back of her blazer, as well as blurring as she turns her head around towards the end of the cut. These artifacts are not present or are significantly reduced in our output. Please see our supplementary for more slow-mo examples, as well as the full user study. This concludes our presentation on improving the perceptual quality of 2D animation interpolation. Please feel free to reach out to us at the University of Maryland College Park or to check out our GitHub at shuhongchen/ASI Anime Interpolator. Thank you for your attention.